Hi, in this video, we're going to talk about a special kind of multicast address, the solicited node multicast address. It's a bit of a long video, but I think it's important to understand the solicited node. I was going to break it up into several shorter videos, but I just think it's nice to just go ahead and keep all of this together. So let's get started. So a solicited node multicast address. For every unicast address, whether it's a global unicast address or a link local address, there's a special solicited node multicast address that's associated with a specific unicast address. Okay, so first of all, how are these used? We're going to see an example later that solicited node multicast addresses are used in neighbor discovery for things like address resolution, when the device knows the IPv6 address but needs to know its MAC address. That's what's known as a neighbor solicitation message. And we'll see a couple of things here, but don't worry about it right now. The destination IPv6 address is a solicited node multicast. And the destination MAC address, the Ethernet destination MAC address, is also a multicast. And you might even see a little relationship here. We'll get there. We'll get there. Okay. So first of all, displaying the multicast addresses on a router. We'll take a look later at how to do this on a Windows PC and on Linux. But remember I said for every unicast address, there is a solicited node multicast. So here we have a global unicast address. It actually has a solicited node multicast address associated with it. Here's the link local address, and there's actually a solicited node multicast address associated with it. And as I mentioned before, you'll notice kind of a relationship between these. Look at this last part of the global unicast address and the last part of the global unicast of the solicited node multicast. Same thing here. Okay, there's an association. There's actually the last 24 bits match. That's not on accident. We'll get there. Okay, so I said for every unicast address there is a solicited node multicast address. Okay, it's created automatically when the device receives or creates a unicast address. For example, the global unicast address, there's a associated solicited node multicast address. Same thing for the link local unicast address. Okay, so there's a direct relationship between the unicast and the solicited node multicast address. We'll see that the way it is formed is by using this weird looking 104 bits, that's that FF02:1:FF, and then using the low order bits, the last 24 bits of the unicast address, that's added to the last 24 bits of the solicited node multicast. Okay, and like other multicast addresses, we'll see later that this actually gets mapped, then the solicited node multicast can get mapped to an Ethernet MAC address, which is also multicast. Let's take a look at how this works. All right, so here's a global unicast address on router R1, 2001 DB8 Cafe :1:1. Okay, so I've broken out the interface ID here, and actually in red, we have the last 24 bits shown in red. And this will become evident next. This global unicast address has associated with it a solicited node multicast address. Here's the first 104 bits. And there's a reason why I have FF in blue. But what happens is the last 24 bits of the global unicast address gets copied to the last 24 bits of the solicited node multicast address. Yep. But this is where the magic happens. Then this IPv6 solicited node multicast address can then get mapped to an Ethernet MAC address that's also multicast. So the first part of the MAC address, okay, 4, 8, okay, 16, these first 16 bits is 3333. Then the next 32 bits, that's why I got FF in blue, FF from the solicited node multicast address and the 24 bits from the unicast, global unicast address, all gets copied in to the Ethernet Ethernet MAC address, which is a multicast. I'm going to show you how all this comes together in a moment. Okay, but what's happened here is 24 bits got copied from the unicast to the multicast, and then 32 bits got copied from the multicast to the MAC address. What this allows is for the NIC card that receives this Ethernet frame, that receives this, to actually filter based on this address. Meaning, do these 24 bits here, do they have any relevance to me? Do I have an IPv6 multicast address, which will also be a unicast address, that maps to this? Do I need to copy in the rest of this frame, or can I ignore it? We'll see how this works more in a moment, but I hope you're beginning to see the effect. So here's the advantage to an Ethernet NIC card being able to filter on the Ethernet destination MAC address. In IPv4, we use a broadcast. It's a destination. The destination MAC address is a broadcast. Okay, IP isn't even involved. Okay, what that means is every device has to accept this Ethernet frame and process the ARP request to see if this frame was for it. Okay, so all the NICs must accept this Ethernet broadcast. Okay, and then the ARP process must check this ARP request to see if the IPv6 address in here matches it. And as you may remember, everybody goes, nope, not me, nope, not me. And then finally this device goes, oh yeah, that is me that you're looking for. But it has to be processed by all devices. Okay. I got some flashing going on there. Okay. In IPv6, what happens is we have this neighbor solicitation message. Neighbor solicitation message, similar to ARP, but it actually uses a solicited node multicast address and gets mapped to an Ethernet MAC address. I'll show you this in more detail, but later in this video. Okay, but what happens is the NIC card can see, look at this, and go, is this for me? So the NIC card can actually filter it, as we can see here and here. It doesn't have to pass it up to a higher process for filtering. Okay, this NIC card says, oh, this potentially is for me, so let me accept it. Okay, like I said, we'll see some details of how this works in just a moment. Okay, so the Ethernet NIC can actually filter the MAC address, okay, the multicast MAC address. Just a little trivia here. You're probably not wondering, but here's some trivia for you. Why 3333 at the beginning of the MAC address? Why was that chosen to be to designate a multicast MAC address for IPv6? Here's a little trivia for you. I'm going to see how all of this works in a moment. But what we're seeing here is in the, let me make sure I cover this. In this ARP request, it's actually called a neighbor solicitation message. this device is looking for this IPv6 address. That address gets mapped to a solicited node multicast, which then gets mapped to a destination MAC address. So then every NIC that receives this Ethernet frame, let me do it like this, can decide by looking at the destination MAC address, is this relevant to me? Does this last 24 bits, is that something I need to normally process? We'll see an example in just a moment. But why 3333? Interesting enough, 3333 Coyote Hill Road, here nearby in Palo Alto, California, was the address of Xerox PARC. Remember who Xerox Palo Alto Research Center was responsible for? They developed the Alto. They were actually responsible for the first graphical user interface. They were responsible for Ethernet and object-oriented programming. Okay, little call out to them here in IPv6. All right, so we saw how it's created. Okay, we saw that every device has the following. It has for every unicast address, here I'm showing a link local address, the device assigns a solicited node multicast and also maps it to a destination MAC address, okay, or an Ethernet MAC address. Let's see how this all works, okay. And I'm going to talk more about this. I have an example coming up at the end, so bear with me on this, okay? But let me suffice it to say this before I move on to the next slide. When a device has a link, has any unicast address, it automatically creates this solicited node multicast address, okay? So that means it will accept any packets for this link local address. So any packets with this destination IPv6 address, I'll put destination at the top here. So any destination packet with a destination IPv6 address, it says, you know what, it's for me, I'll accept it. Also, if any packets that have this solicited node multicast address as the destination, I'll accept it. But you know, I don't have to wait for my IP process to determine whether or not I accept it. This is encapsulated in an Ethernet frame with a destination MAC address. And I will accept anything with this destination MAC address. A lot of arrows here, okay? Because I know that these last 24 bits here might belong in the Ethernet destination MAC address. Chances are belongs to one of my unicast addresses. Okay, so here is an example of, well, wait a minute, the last 24 bits, isn't it possible that two devices have the same last 24 bits? Here we have PCA and PCB, both having, they're different addresses because the last 64 bits is different. But it just so happens the last 24 bits is the same on both these devices. So yes, they are going to have the same solicited node multicast address. Does that create a problem? The answer is no, okay? Because what will happen is both Ethernet NICs will accept the Ethernet frame, okay? But what will happen is the ICMPv6 process, when it goes up, just like an ARP request, will have to examine what address is being looked for. And when it looks at the entire address, the entire IPv6 address, are you looking for this address? PCA will go, that's me. PCB will go, that's not me. I'm going to show you an example. Okay, so here we have PCA and PCB. Okay, so we have a device that is looking for this IPv6 address. Why is it? Because it needs the MAC address, like an ARP request. This is known as a neighbor solicitation message. Hey, I know this IPv6 address. What is your MAC address? So it sends out this neighbor solicitation message. Okay, this target address has been mapped to a solicited node multicast, which then gets mapped to a destination MAC address. So both PCA and PCB receive this frame. PCA has this address here, global unicast, and PCB this one. So both of these addresses get mapped to the same solicited node multicast address because the last 24 bits are the same. So they also get mapped to the same Ethernet MAC address. Okay, so we have the same 24 bits here. Okay, so both of them receive this destination, this neighbor solicitation message. It's a multicast, so the switch is going to forward it out all ports, excuse me. So they both go, you know what? It's for me because we both map to this MAC address. Okay. So then they pass it up to their IPv6 process, and they both go, oh, yep, this is a solicited node multicast address that I need to look at because that maps to one of my unicast addresses, the last 24 bits. So they both have to process it at the IPv6 level. Again, this is only in the case when the last 24 bits match between PCA and PCB. Okay. They pass it up to their ICMPv6 process, and PCA goes, oh, you're looking for this address here, huh? Well, you know what? That's me. PCB goes, oh, you're looking for this entire IPv6 address? Although the last 24 bits match me, not this whole address doesn't match me. So this is not for me. So again, this is only in the rare cases, when you have the last 24 bits match between two devices on your network. Okay, so I'm just showing you from the book here some different global unicast and link local unicast addresses. Okay, so here's they get mapped to a solicited node multicast. Then it gets mapped to an Ethernet multicast MAC address. Yeah. So basically, router R1 will accept any Ethernet frames that, first of all, have its own MAC address for that interface, plus any multicast addresses for either of these. Same thing with WinPC. It'll accept any destination MAC addresses that belong to either of these multicast addresses, plus its own MAC address for the NIC. Linux PC will accept any Ethernet frames with the destination MAC address that belongs to one of these two addresses, plus the MAC address that belongs to its NIC. Okay, so that's what I'm kind of showing here. Is WinPC is saying these are the layer 3 addresses I accept, and these are the layer 2 addresses I accept. Okay, so as we can see here, this is what was configured. The global unicast address, let's say, was received, and maybe we configured a link local address, or it created one on its own. Looks like we didn't do it. This is WinPC. So the link local address was created on its own. Both of these got mapped to a solicited node multicast address. And then both of these got mapped to an Ethernet multicast MAC address. So it will accept MAC addresses that belong to one of its solicited node multicast addresses that belong to one of its unicast addresses. Okay, MAC address to multicast to unicast. But here's the MAC address of its actual NIC card. Of course, it will accept any Ethernet frames for that destination MAC address as well. Okay. So again, we're mapping unicast addresses to a multicast solicited node, so we can then map that to an Ethernet MAC address. Why is this a good thing? Again, in Ethernet, IPv4, we have broadcasts in IPv4. Every NIC card has to process it, like an ARP request. In IPv6, we can use multicasts. So let's map what the address we're looking for to a solicited node multicast address, so then we can map it to a multicast MAC address. And that way we can actually filter it at the NIC. Okay. Solicited node multicasts are always forwarded out all ports by the switch. In IPv4 and IPv6, we have ways to filter some multicast addresses. But a solicited node multicast actually gets flooded or forwarded out all ports by the switch. Okay, so once again, here we have a NIC card. Here's its MAC address. This device, PC2 in this case, is going to accept any frames. This NIC card will say, hey, this is my MAC address. Any Ethernet frames with this destination MAC address, I'll accept. Oh, what happened here? Looks like I have my PowerPoint went bizarre on me. That's okay. We also have this global unicast address. The last 24 bits got mapped here, which also then got mapped here. Okay, 32 bits with the FF. Okay, so it says this Ethernet NIC says, I'll accept any of those as well. Oh, I also have a link local address. The last 24 bits got mapped to a solicited node. And then I have an Ethernet MAC address associated with that. So notice the last 24 bits are the same on all three. I'll accept any Ethernet MAC addresses for that. Oh, you know what? I'm also, because I'm enabled for IPv6, I'll also accept any multicast MAC addresses for that are associated with the multicast address, all IPv6 devices, which is sent out as a multicast in the Ethernet frame. Okay, so multicast is always much better because it allows the NIC card to possibly filter the frame without having to pass it up to other processes like IP or ICMPv6 before the device makes the determination whether it needs to process it or not. We can verify solicited node multicast addresses. We saw this earlier. So here's, again, now this hopefully makes a little bit more sense. Here's our global unicast address. Here's the solicited node multicast address for it. Here's our link local address. Here's the solicited node multicast address for that. So this device will accept any IPv6 packets with any of these 4 destination IPv6 addresses. And of course, these will get mapped to an Ethernet MAC address that the NIC will now be able to accept based on the destination MAC address. Okay. So how do I look at this on my Windows machine? Okay, so in Windows, if you remember, we looked at this earlier. I can do ipconfig, get my global unicast and link local addresses. If I do netsh interface IPv6 show joins, it shows the solicited node multicast addresses for both. So yeah, take a look at that if you've got a Windows machine. In Linux, I can do ifconfig, shows me both my global unicast and link local, and I do netstat -g, and I can see the solicited node multicast addresses associated with both those unicast addresses. Okay, here's a little bit of an example. Okay, remember in IPv4 we use ARP. Okay, I know your IPv4 address, but what's your MAC address? Check the ARP cache, not in there. I send out an ARP request, broadcast, and I get an ARP reply. And I put in the ARP cache. In IPv6, we use neighbor solicitation message and neighbor advertisement. So I know your IPv6 address, but what is your MAC address? Okay, so let me check my neighbor cache, which is similar to an ARP cache. It's a mapping of IPv6 address to MAC address. If it's not in there, I'll send out a neighbor solicitation message. Hey, who out there has this IPv6 address? Send me your MAC address. PC2 says that's me. Let me send you my MAC address in a neighbor advertisement message. And that gets put into the neighbor cache of PC1. We can actually, this is what it looks like. Here's the IPv4 ARP request. Okay, it's a broadcast, no IP involved, sent out and processed. Because of the broadcast, all devices actually have to process it. The NICs, all the NICs accept it. All the devices, ARP process has to look at the target IPv4 address. So it must be passed up to that layer for further processing. In IPv6, once again, that target IPv4 address is in an ICMP-v6 neighbor solicitation message. That address got mapped to a solicited node multicast that got mapped to a multicast address in Ethernet. There's my little animation where I'm supposed to talk about that, which I did. So the destination IPv6 is a multicast. The destination MAC address is also a multicast. So this enables the NIC cards to process it. Is this a multicast address that belongs to me? Is it mapped to one of my solicited node multicast addresses, which is mapped to one of my IPv6 unicast addresses? Okay, here's a little example. I'm using uppercase here, but that's okay. So we do a ping. Okay, so showing the neighbor solicitation message. Neighbor solicitation message sent is the destination. So if we look at, let me back up one here. So this is the address I'm looking for right here. It's in the ICMP v6 neighbor solicitation message. Okay, that's going to get mapped to a destination IPv6 address, which is a solicited node multicast address, the last 24 bits. Then that'll get mapped to a destination MAC address, the last, well, 32 bits, including the FF. But the last 24 bits is what carries over from the target IPv4 address. Okay, that goes out as a neighbor solicitation message. When this device receives that Ethernet frame, it says, oh, wait a minute here. The destination MAC address, 3333FF000200. Let's see. Oh, you know what? I have a solicited node multicast address, which is from my global unicast address, and I'm going to accept this frame because although it's not my MAC address here, it is associated. I do accept any destination MAC addresses associated with this last 24 bits here. So we'll return a neighbor advertisement message with its IPv6 address and its MAC address, and that will put in a neighbor cache, and then now the device can go ahead and send out the ICMP v6 echo request. Okay, we're almost done here, but what I'm showing you here is the actual Wireshark capture of that neighbor solicitation and neighbor advertisement. Okay. So this is a neighbor solicitation message, ICMP v6 type 135. Here's the address that the device is looking for. It knows the IPv6 address, needs to know its MAC address. This gets mapped to a destination MAC address, solicited node multicast, solicited node multicast address, I should say, which will be used as the destination IPv6 address. I think I said MAC address, sorry about that. But that'll get mapped, so that the last 24 bits got mapped here in red, and then we'll map the last 32 bits. Oh, by the way, the source address is its own address as it's coming from me. But we'll map those last 32 bits, but really what's important here is the 24 bits carryover from the target IPv6 address. Okay, so all devices will, just about all devices on the network will ignore it unless it has a unicast address that happens to map to these last 24 bits. PC2 will, let's go back here, PC2 says, hey, I accept this MAC address because I have a multicast, solicited node multicast address of this destination because this is target IPv6 address is one of my unicast addresses. Okay, so here's the neighbor advertisement. So it's saying, yes, you are looking for me. So let me return a neighbor advertisement message, ICMPv6 type 135. This was the address you were looking for. You knew that already. Okay, but here's my MAC address. This is what you were waiting on. And I'm just going to send it directly from me to you. Just like an IPv4 ARP reply is a unicast. No need for everybody seeing this. I just need it for you. You're the only one that requested it. Okay, so it's going to come from my unicast address, my regular MAC address, and I'll send it to your MAC address, which is the MAC address right here. Okay, so that's the solicited node multicast introduction and advantages. I actually combined the two presentations in one. Know a lot of stuff there, but I hope you begin to see the advantages of this solicited node multicast. It's probably one of the lesser understood as far as people with general knowledge of IPv6. And it's one of those things that they kind of almost don't want to look at. It looks too scary. And it really isn't, is it? Just know that every unicast address gets mapped to a solicited node multicast, which gets mapped to an Ethernet MAC address and allows the device's NIC card to determine whether or not it needs to accept that Ethernet frame. Thanks for listening, and we'll go on to the next video.